Hello Math MAA students. Okay, today we are going to look at mathematical induction. In mathematical induction, we are proving things. Alright, there's 4 steps that we have to look at. Step 1, we have to show that the value of n, everywhere I see a n, I will substitute with a 1. And my left hand side answer should be equal to my right hand side answer. Step 2, assume that n is equals to k. That means everywhere that I see a n, I will replace it with k. Step 3 is proof that n is equals to k plus 1. That means everywhere that was there as n, where I substituted it as k, I will now substitute it as k plus 1. And step 4 is writing the conclusion. We are going to look at a few examples together. Right, example 1. So it says, proof by mathematical induction that 3 plus 7 plus 11 plus some numbers, other numbers, is 4n minus 1, which should be equal to n into 2n plus 1. Okay, that's the mathematical induction that we have to prove. Step 1, we have to show that n is equals to 1. That means in place of n, equations on the left hand side and the equation on the right hand side. I have to substitute the value of n on both sides and see my answer on the left hand side should equal to my answer on the right hand side. As you can see, when I have substituted the value of 1, my left hand side answer is equal to the right hand side answer. Now we are going to look at step 2. Step 2 is not very complicated. It says everywhere you see a n, assume that n is equals to k. So everywhere you see a n, you will substitute it with k. So I had my equation, I had the n here, I substituted it with k, which is equals to, on the right hand side, 2k into 2k plus 1. Okay, you must have seen I've written 3 in a circle here. That means this term I am going to be substituting in step 3, right? It's easy to write a step 3 so that you know this is the thing that you will be substituting in step 3. Okay, let's move on to step 3. Step 3 says prove that n is equals to k plus 1. So I'm going to be writing from the beginning all that, and then I'm going to be adding it together with this. So everywhere that I see a k, I'll substitute with k plus 1. So this is same from the top. Exactly the same. Plus 4 into k plus 1. Instead of k, I wrote k plus 1 minus 1. Right? On the right hand side as well, everywhere I see a k, I'll substitute with k plus 1. That was substituted with k plus 1. That was also substituted with k plus 1. And there. Now I am going to simplify. Simplify my left hand side and simplify my right hand side. My left hand side answer should equal to my right hand side answer. Okay. On this side, can you see this? The one written in black. This is exactly the same as the one in step 2. That means step 2 is equals to this. So wherever I can see this, I will be able to substitute with that. So this is where I am able to see this, and I will be substituting that with k into 2k plus 1. And then that comes down here. Alright, and on the right hand side I have this. Okay, let's walk separately. Let's walk on the left hand side and then right hand side together. Okay, so when I'm expanding, I have to expand all the brackets. The best and the logical way I would say is always expand all the brackets. The expanded form will always give you the simplified answer. Or even you can use common factors, which is sometimes little challenging when you are doing expression, when you're having expressions as common factors. So when I'll expand this, I'll end up like that, and this will be simplified to that. All the like terms collected together, you have this. On the left hand side, I'm left with this. Now let's simplify the right hand side. There you go. Again, I'll be expanding my bracket there, simplifying, and then expanding it again, collecting the like terms, and you'll see this. My left hand side answer is equal to my right hand side answer. There you go. Now my last step, step 4, I have to write a conclusion. In conclusion, you'll see there's one standard sentence that I will always use. It is proved by mathematical induction that this entire thing, right? this entire expression is true for all integers n, right? So that my, you can, instead of the word if, you can write that entire expression that's there, which is equals to which is true for all positive integers n. Thank you.